Hi, this is MAT 221. This is Calculus 1. This is section 4.4. This is Mrs. Johnson. We were talking about relating the original function, the derivative, and the second derivative. And we were just talking about this example number 1. And we wanted to make sure we're be careful here when we talk about the critical points of f is when the first derivative is equal to 0, at -9, at -5, at 8, and at 10. And what I was starting to say in that last video is often we have to be careful about this point right here. Often students want to say that the derivative is not defined at x equals 9. Be careful. We're looking at the derivative, and the derivative is definitely defined. I have a value there. The value of the derivative at 9 is actually -4. Now, the derivative of this function, or the second derivative, is not defined at this cusp. But the first derivative, and that's what we're looking at the first derivative, actually has a value at 9. The value of the derivative at 9 is -4. So it is defined, the derivative is defined at 9. But the second derivative will not be defined at 9. That's where we're taking the derivative of the curve we're looking at. So we always have to be really careful here as we go through. Number 2 says, on what intervals of f of x is f of x increasing? Again, the derivative will be increasing when the derivative is positive, or in other words, when the derivative curve has positive outputs. In other words, where the derivative curve is lying above the x-axis. So in this case, we have from -∞ to -9, the derivative curve is a positive value. From -5 to 8, notice these are all positive values here. And then from 10 to infinity, these are all positive outputs here for the derivative. So the derivative, whenever the derivative is positive, and we're looking at the derivative, then the original function will be increasing on this interval. Just the opposite is true for decreasing. The function will be decreasing whenever the derivative has a negative output or negative values, and that's going to occur from -9 to -5, and then again from 8 to 10. Those all have negative output values for the derivative. Next, it asked us on the interval from, on what intervals is f of x concave up? Again, let's go back and see what we remember. Remember, the concavity of the curve is linked to the second derivative, or the direction of the derivative curve. Remember, when the second derivative is positive, the derivative curve will rise and the original curve will be concave up. So let's look. Where is the derivative curve rising? Looks like there. And again, over here, the derivative curve is rising. So we say f of x is concave up whenever the derivative curve is increasing, and this occurs from -7 to -1, and then again from 9 to infinity. Just the opposite with concave down, wherever the derivative curve is decreasing. So that would be from -∞ to -7. And then we would say from -1 to 6. Notice at 6, it looks like the derivative levels off there a little bit. This doesn't change here for a second, but then it goes back again. Oops, I'm sorry. Here we go. So we would go down again. So the derivative is decreasing, right, till here, and then decreasing again. Now, if you had not put that and stopped at 6, I would have said that was okay. But for the most part, we have to remember when the curve levels off a little bit, we're neither increasing nor decreasing at that point. So we'd say we're decreasing till 6 and then decreasing again from 6 to 9. Next, in question 6, it asked me what x values does the function f of x have a local max? Again, always reminding yourself you're not looking at f of x, you're looking at the derivative of f of x. And local maximums and minimums occur at critical points. And remember, critical points were at -9, -5, 8, and 10. So we're going back to those critical points of f. and saying, okay, where does the derivative change sign from positive to negative? Because remember, f of x has a local max or min whenever the derivative is equal to 0 or does not exist, critical points, and a local max when the derivative changes sign from positive to negative. So notice the derivative has positive outputs, then a 0 output, then negative outputs. So there's 1 at x equals negative 9. Here's another critical point, but not changing the way we want it to. This critical point, the derivative is positive values, then a 0 value, then negative values. Yep, that works from positive value to a negative value around a critical point. So at x equals negative 9 and x equals 8, we have local maximum values. Obviously, just the opposite for local mins. Local mins will occur here when the derivative changes from negative to positive, and you can see at x equals negative 5 and at x equals 10. Next, it asks me for where does the function f have points of inflection. Now remember, points of inflection occur when the curve f of x changes concavity, and changes in concavity occur either where the second derivative changes sign or when the first derivative changes direction. So we look here and say, well, f of x has points of inflection wherever the second derivative changes sign, or again, where the first derivative changes direction. So we look, we have the second derivative, so we think derivative of the derivative. So the second derivative is negative here, then 0, then positive. So notice the second derivative change sign at x equals negative 7. And then the second derivative is positive here, and then 0. And then the second derivative is negative on this side. So the second derivative again is changing sign at x equals negative 1. The second derivative is negative, 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 0, but then negative, 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 until we get to 9. So we have a negative second derivative until we get to positive 9. And then we have a positive second derivative. So again, the second derivative is changing sign, point of inflection, at x equals 9. All right, that concludes section 4.1. You have no WebAssign for this particular section because it's very graphical, but you do have a worksheet that I gave you in class on section 4.4 that I'd like you to do for homework where you're doing these same type of skills. You can also look in the worksheet folder to look for interpretation of the derivative sheet B, which is very similar to the first one I did on these PowerPoints, that will help you to, again, try to come up with these concepts that we need for those relationships between the derivative, the first derivative, the original function, and the second derivative. Have a good day.